Hey everyone, so today we are going to see the concept of statistic with the help of two examples, and after that we are going to see the concept of sampling distribution. Okay, so that is the main agenda of today's session, and during this we are going to see some concepts like population, sample, then when do you say a random sample is iiD, independently identically distributed, and when a sample is said to be biased or unbiased sample. Okay, so these are a couple of things that we are going to see. Okay, so before giving you the actual definition, let us try to see this with the help of an example. Now see, whenever after the election gets over, if you see any news channel, you will see that they come up with the exit poll that okay, from here this party is going to win, from there that party is going to win. So when they conclude that from a particular constituency a particular party is going to win, do you actually think that the news reporter will go to each and every eligible voter and ask him or her to whom he or she voted? No, that is not technically possible, right? You cannot just survey the whole of the population. So what you do, instead of surveying whole of the population, you take the samples. Now suppose in a particular constituency where you want to determine which party is going to win. So suppose there are three parties, say party A, party B and party C. Okay, so they can be any parties. Okay, so I don't want to go into the politics, but if you are following Indian politics, then A, B, C indeed represent one or the other party in India. Okay, but there are some parties A, B and C, and obviously from some constituency we want to see which party is going to win. So obviously it's a big constituency, it's not possible, it's not feasible to ask each and every voter. So you take a sample. So suppose there are 100 wards, for example, there are 100 wards in that constituency, so you go into each ward. So from first ward, so you take some sample. Okay, so you are going to the first ward, and suppose there are plenty of people, among them you are only taking 50 people and asking them that whom they voted for. So one will say I voted for B party, one will say for A party, B party, C party and so on. Then you go to another ward. There again you are not going to survey the complete ward. In that ward you are going to ask 50 people that whom they voted for. Third ward, fourth ward and so on till 100 ward. Okay, so in each ward you go and ask few people that whom they voted for. Now again here also, while taking this sample of 100 people, we should be careful, or I said 50 people, right? So while taking the sample of this 50 people, you should do a nice kind of sampling. Nice as in you should ask the people, suppose you should ask 5 people from the age 20 to 30, you should ask 5 people from the age 30 to 40, then 40 to 50, then 50 to 60, 60 to 70, 70 to 80. So from each category you should ask the people. Then only we will say it's a good sample. And that's why, just a digression from here, that's why samples are usually categorized into two parts. One is biased sample and unbiased sample. Okay, so even before that, now what is a sample? So sample is nothing but a subset of a population. Now again the question, what is population? Population is anything that you are going to study, or the characteristic that you are going to study. Like here I am going to talk about which party is going to win. For that I am going to study the population, the human beings in a particular constituency. It can consist of animals, birds, or it can consist of trees, or population can also consist of numbers as in number of tweets per day, or number of followers or unfollowers per day, number of revenue generated from particular sales. Okay, so population is anything which we are studying or which is of interest to us. Okay, so that is a population, and when you take a subset of that population, it is called as a sample. Now coming back to the types of sample, there are two types of sample: biased sample and unbiased sample. We should always go for unbiased sample. Now when you say sample is biased or unbiased, so suppose like here I said, when you are taking a sample, make sure you ask the people of each category. There is no point of asking only the people which are 60 above, because then you are not getting a proper answer. Okay, similarly, like suppose if like in my class there are 130 students, and from looking at their heights I know that okay, if I measure the height, average height will come out to be 5.7 inches. So but if I take a sample of suppose say 50 students or 30 students, and if the average is coming out to be 5.1, then that's a huge difference, 5.1 and 5.7. But if the average is coming out to be 5.55 or 5.56, then that's okay. Suppose I am taking one more sample which is giving me the average height, average of 50 students, and the average height is 6.1, then that is also way beyond 5.7. Okay, so any sample that is either overestimating or underestimating the value, then those samples are called as biased samples. So we always prefer unbiased samples. So that's why when we are doing sampling over here, you should ask people from each and every age category. Then we'll see that the sample is a good sample. Okay, now what was our main aim? Main aim was to see who is going to win from a certain constituency. So you went to each ward and you selected 50 people and you asked them for their vote, to which party they voted for. Now from here, suppose you look, suppose first person voted for B, second A, and so on. Now you find which party has got maximum votes, right? Or statistically speaking, we say you find the mode of this. So suppose B is repeating most number of time, so therefore the mode is B. Or from this side we conclude that B party is getting maximum vote. Then again you come here, again suppose B is repeating more number of times. Suppose here you are getting C, here you are getting B, then you are getting A, then you are getting B, and so on. So you find the mode from each of these outputs. So this collection, the output that you are getting from samples, well, we are going to see that this is called as a statistic. Okay, I will give you the proper definition. But what is a statistic? The outputs that you are getting from the samples, then this collection of outputs is called as a statistic. Okay. And now finally I want to conclude. So what you do is, from here also you find the mode, which part is winning maximum number of times. So from here you can see, oh, B is repeating more number of times. So therefore from this constituency, B party is winning. Okay, so that is the overall idea. You have a population, it's difficult to study the whole population, so you take the samples. Once you have the samples, you try to get the results from each samples. The results from each samples is what we call, that collection is called as a statistic, and we try to get the output from this statistic about the population parameter. Okay, so that's what the overall idea is. And now what is the sampling distribution? Now see, these are all random values. Why? Because these are random values. So these are also random values. So statistic is a random variable. And when we draw the probability distribution of this, then that probability distribution is called as a sampling distribution. Okay, so sampling distribution is nothing but the probability distribution of a statistic. So suppose you have A, B, and C. Okay, now suppose here out of this 100 words, B is coming 50 times, A is coming 25 times, C is coming 25 times. So what is the probability of B? It is 1 by 2, 50 by 100. What is the probability of A and C? 1 by 4 and 1 by 4. Or if you draw a histogram, this is what you get. So the sampling distribution of a statistic, the probability distribution of a statistic is called as the sampling distribution. Okay, so I hope you have got the rough idea. Now let me tell you in more detail along with the proper definition and one more example involving numbers. What is a statistic? It's a function consisting of random variables. That means what? Suppose you have some collection of random variables. Okay, you have this collection, say xi's. Okay, this belongs to my some space omega. Okay, so what is a statistic? X is a statistic from omega to r. It's a function whose domain, whose inputs are nothing but random variables. So like suppose if I take x1, so if I take f of x1 comma x2, I am writing as x1 square plus x2, where x1 and x2 are random variables. So this is a function involving random variables. So this is a statistic. Okay, or I can take anything. So if I take x1 plus x2 plus x3, if there are 3 random variables, then this is a function consisting of random variables. So this is also a statistic. Okay, but the main statistic that we use are sample mean, sample median, standard deviation, or the sample variance. Okay, so these are the main statistics that we usually use. Okay, so let us concentrate on a sample mean. So how a sample mean and a sample standard deviation comes into picture. So for that, let me take an example. So suppose my data set consists of numbers, say 2, 8, whatever, say 12 and 16. And let's take one more number, say 20. Now just for the calculation purpose, I am taking this small set. Otherwise, when you play with the real world data, you have a data consisting of 70 million lines, 80 million lines. You have a huge data, right? But okay, for understanding purpose, suppose this is my data set. Now you take all possible sample size, all possible samples of size 3. Okay, so you take suppose 2, 12 and 16. So I want to find the average of this. Well, this is a small data set, you can easily find the average. But suppose if you have a big data set, then what you do is you take a sample and then find the average of this sample. So what is the average in this case? 16, 28, 30. So average is 10. Then you take another sample, so it will be suppose 2, 16 and 20. Again you find the average. This is how much? 36, 38, 38 by 3. So 12.33 I think, or 12.6, 12.67 I think, whatever. Then again you take one more sample, say 16, 12 and 2. You take one more sample, 18, 12 and 20, 2, 8, 16. So you keep on taking the random samples of size 3. So you get all possible values. Okay, and you keep on taking their averages. Okay, so this is the first position. Now this can take any values, so I am calling this as capital X1, the first set of values. This is my second set of values, so I am calling it X2. This is the third set of values, so I am calling X3. So X1 is a random variable, X2 is a random variable, X3 is a random variable. And they are independent because I am choosing the numbers independently. So X1, X2, X3 are independent random variables. Okay, that's one thing. Second thing to observe, when I take all possible samples of size 3, all these numbers are going to repeat. Okay, so 2, 2, 16, 18, all these things, the numbers which are coming here, they will come here as well. In some order, but they will come here as well. And these numbers will come here as well. So that means what? When you draw the probability distribution for X1, we draw the probability distribution for X2 and that of X3, all three of them will have the same probability distribution. Because we are taking all possible samples, so therefore all of them are going to come in one or the other samples and at some positions. So when you find the probability distribution of Xi's, all will be same. Suppose it is f of x. So x1, x2, x3, they are independent random variables and they are having the same probability distribution. So for them, the word is independently identically distributed. You will see this phrase many places, iid. Suppose x1 to xn is a random sample which is iid. That means this x1 to xn, these samples, they are independent and they are identically distributed. That means they have the same probability distribution. Okay, so that is one more term that you may come across. Okay, coming back to this. So you find the average of this, you find the average of this, you find the average of this and so on. So this I will denote by say x1 bar. This is the average of the second sample. So I will denote by x2 bar. Then take the average of third sample, x3 bar, x4 bar and so on. Now these are also random values. These are numbers. Earlier when we were finding the mode, the number of the parties, that is the party that is getting the more number of votes. So that means we found the mode, right? The mode for the from the first ward, mode from the second ward and so on. So that output we call as a statistic. Similarly, once we have a sample, from this sample we are finding the averages. We are finding the averages. So this collection of output we call as a statistic. So statistic is nothing but the collection of outputs which you are getting from the samples. And since I am taking the averages x1 bar, x2 bar, so this I will denote by capital X bar. So this is also a random sample. Okay, this is also a random variable because all these values are random, because these values are random. So X bar is nothing but a random variable. So, and the good way to write is, what is X bar? If you observe, your X bar is nothing but you are taking the average of this, then average of this. So this plus this by 3. Okay, so first entry is coming from this x1 variable, second entry is coming from the second variable x2, and the third entry is coming from the third variable. So one can write X bar as x1 plus x2 plus x3 by 3. So you can see it is a statistic, it is a function whose consisting of random variables. So that is a proper way of saying any function which consists of random variables, it is called as a statistic. But if you want to understand properly, it is nothing but the outputs that you get from all possible samples. Okay, so statistic is always related or associated to samples. You will see the word parameter. Parameter will always be related to the population. Okay, so parameter will always refer to population, statistic will always refer to sample. Okay, so these are the two words, and make sure this differentiation is clear. Okay, whenever I say consider the parameter mu, that means I am talking about the population. Consider the statistic, that means I am saying we are playing with the samples. Okay, so this was an example of one statistic which was x bar, sample mean. But okay, I am not interested in sample mean. So suppose I wanted to find the median. So let me denote by x tilde. So you find the median from this. How do you find the median? Arrange in increasing order and you find the middlemost value. Okay, if you have odd number of terms, you take the middlemost value, and if you have even number of terms, then what is the median? It is the average of xn by 2 and xn by 2 plus 1. Okay, so that's how you find the median. So if I want to write in terms of the this variables, random variable, what is x tilde? It is nothing but the middlemost value xn plus 1 by 2 whenever you have the odd numbers, when n is odd, and when n is even, you take xn by 2 plus xn by 2 plus 1 by 2 when your n is even. So you take the middlemost value. So when n is 3 plus 1 4 by 2, which is 2, so you take the middlemost value. Okay, so again you can see the median is nothing but it is defined in terms of function, in terms of random variables. So x tilde is also a statistic. And what is the value? You find the median of this, which is x1 tilde, you find the median of this, which is x2 tilde, median of this x3 tilde. So x tilde is nothing but the collection of all these values, all the medians from the sample. Okay, so this is called a sample median. Sample mode, I already talked about B, A, C. Okay, so we already talked about the sample mode. Then comes the concept of sample variance. We denote sample variance by capital S square. Okay, so you find the variance of this, I will denote by small s1 square. You find the variance of this, I will denote by small s2 square. Find the variance of this, small s3 square, and so on. And this collection we denote by capital S square. And what is the formula for variance? Well, for sample variance there is a exception. If you recall very earlier lectures, what was the definition of a variance or variance of a random variable x? It was average expectation of, it was x minus mu the whole square, and x belongs to x, and you divide by n. Suppose there are x is going from 1 to n. Okay, so xi minus mu, I is going from 1 to n. You take average of the deviation from the mean square and you take its average. This was the definition of a variance of a random variable. But when you are playing with the variance of a statistic, so if S square is nothing but the statistic, collection of all variance, what is the formula for this? The formula is you take 1 upon n minus 1 summation xi minus, if this is x bar, the x bar statistic, so xi minus x bar, the whole square, I is from, in this case 1 to 3, in general 1 to n. So when you are playing with sample variance, instead of dividing by n, we divide by n minus 1. And the reason being, we are going to see in the next chapter when we will see estimation theory. One reason I can say as if now, if when n is very large, dividing by n or n minus 1 doesn't make difference. If suppose your n is 1000, dividing by 1000 or dividing by 999 doesn't make that much of a difference. But again, this is not a valid or the good argument. You will say, okay, divide by 998 or 997. But okay, just for the sake of completeness, I am telling this as an argument. But the good reason is about the estimation that we are going to see in the estimation theory. Okay, so as if now just take this for granted that to find the variance, we always divide by n minus 1, sample variance, okay? We divide by n minus 1 and not n. So these are very important statistics: sample mean, sample variance. This and sample median as well, we are going to refer for some of the times. Okay, so we talked about statistic, iiDs and sampling distribution. Okay, so yeah, sampling distribution is nothing but you find the probability distribution of a statistic. So once you have a statistic, say x bar, you find this probability distribution. Once you have the statistic s square, you find this probability distribution. And whatever the probability distribution you get, suppose for x square you are getting something like this. Okay, so you have this x1 bar, x2 bar, x3 bar, x4 bar, and so on. You have all possible means, and then you find this probability distribution, and whatever the graph you get, or whatever the probability distribution of the statistic you have, then that probability distribution is called as the sampling distribution. Okay, so before concluding, let me just prove this last result. Now, like for variance, we have seen when we talked about the variance of a random variable x, it was nothing but expectation of what? X minus mu the whole square, right? But then we had one more very nice formula, which was nothing but expectation of x square minus expectation of x the whole square, which we used very widely. Similarly, we have a very nice alternate formula for variance of a sample. It says it is nothing but 1 upon, if you take this n inside, so 1 upon n minus 1 into summation of xi square, kind of you can relate from here, minus 1 upon, minus if you take this n inside, so minus 1 by n summation of xi the whole square. Okay, so you can relate this theorem with this theorem in a nice way. So proof is simple. So what is my s square? S square is 1 upon n minus 1 summation I from 1 to n xi minus x bar the whole square. Now when you expand this summation xi minus x bar the whole square, what do you get? You get summation xi square minus 2x bar summation of xi plus summation x bar square, right? This is what you get. But now what is this? This is 1 upon n minus 1. This is summation of xi square minus 2x bar. What is summation of xi? So x bar is what? Summation xi upon n. So what is summation xi? It is n into x bar. So you have 2x bar square n, and this is what? This is nothing but summation of, again this x bar square will come outside, and summation of 1 is n, because I is going from 1 to n. Okay, so this is independent of I, so this will come outside. Summation of 1 is n. So what is this? This is nothing but 1 upon n minus 1 summation of xi square, and this is what? Minus n into x bar square. But now what is your x bar square? X bar square is nothing but summation of xi square upon n square, because x bar is nothing but summation of xi upon n. So that one n will get cancelled, and when you take it outside, this is what you get. Okay, so that is the proof. So I hope this part is clear, and if you have any doubt, you can ask me in the comment section. Thank you.